Hi everyone, welcome back to our problem set videos. In this video, we're going to be using percent composition to find empirical and molecular formulas. We are going to work through three different problems. Let's go ahead and get started with our first one. So the first question reads, the percent composition of an unknown compound is as follows, and it gives us our percentages of carbon, hydrogen, and oxygen. Then it simply asks us what is the empirical formula of the unknown compound, and it also asks if the molar mass of the unknown compound is 106.12 grams per moles, what is its molecular formula? The first thing we need to do is find its empirical formula. Now, we have been given the percentages of carbon, hydrogen, and oxygen. The easiest thing to do is just to assume that you have 100 grams of this unknown compound. That converts the percentages into grams. So instead of having 79.23% carbon, we now have 79.23 grams of carbon. Of course, we do the same thing for our hydrogen and oxygen. Once we have grams of carbon, hydrogen, and oxygen, we do a very simple conversion of grams to moles for each of these. So just to run through carbon, here again is my 79.26 grams of carbon. I use my molar mass, make sure my grams of carbon cancel, so I have moles of carbon. And I simply calculate that out, so I have 6.599 moles of carbon. You do the exact same calculation for your hydrogen and your oxygen, so you have number of moles for each of your elements. Once we have the moles for each of our elements, we are looking for the smallest number of moles. In the case of this problem, that is going to be our moles of oxygen. It has the smallest number of moles. We then take that number of moles and we divide all of the other moles by it. So here for my carbon, this is my 6.599 moles of carbon. I am dividing by the moles of oxygen here, again, just because it's the smallest. Now when I do this, I get 7.013. When I do the same thing for hydrogen, again, dividing by the moles of oxygen, I get 6.010. And of course, when I divide my moles of oxygen by the moles of oxygen, I get exactly 1. Now, for empirical formulas, we are obviously looking for whole numbers. So we assume that our 7.013 is 7. Our 6.010 is 6. That means we have 7 carbons, 6 hydrogens, and 1 oxygen. So here is our empirical formula, C7H6O. So we have completed our first task. We have found the empirical formula for this unknown compound. The next part of the question asks us what the molecular formula is. The first thing we need to do is we need to calculate the molar mass of the empirical formula. Now when we calculate that, we get 106.12 grams per moles. Now if I scroll up back to the original problem, you can see that they gave us the molar mass of the unknown compound to be 106.12 grams per moles. Therefore, our empirical formula is our molecular formula. It's nice when you don't have to do any more work on these. Let's go to our second problem. This one reads, an unknown acid is found in the lab. There are 5 bottles of acids on the shelf. We have phosphoric acid, citric acid, benzoic acid, acetic acid, and tartaric acid. Now, the unknown acid is found to contain 68.85% carbon, 26.20% oxygen, and the remaining is hydrogen. And we want to know the identity of the unknown acid. As you will see, this is essentially the same problem, but it gives us a little bit of a twist. The first thing we need to do is we need to calculate the percent hydrogen. Our problem gives us our percent carbon and oxygen, just says the remaining is hydrogen. So let's get a number for that percent hydrogen. Of course, all our percentages must add up to give us 100%. So I am simply going to add my percentages of carbon and oxygen and figure out then what percentage remains that must be hydrogen. So our simple addition subtraction problem, and you get almost 5% hydrogen. Now, just like in our previous problem, I think the easiest thing to do is just assume you have 100 grams of this unknown compound. That converts all of our percentages straight to grams. So now we have 68.85 grams of carbon, 26.20 grams of oxygen, and 4.95 grams of hydrogen. Continuing on, we are going to take each of these grams and convert to moles. Again, if I just focus in on the calculation for carbon here, I'm using the molar mass of carbon to convert from grams of carbon to moles of carbon. So I'm getting 5.732 moles of carbon. Here are my moles of oxygen and my moles of hydrogen. Just like before, I need to find my smallest number of moles, and that's what I'm going to divide by. In this case, again, it is oxygen. So now I take each of my number of moles, and I am dividing by my moles of oxygen. Here are the numbers I get when I do those calculations. Now I'm looking for whole numbers. Well, obviously, my 1 for oxygen is exact. That's not a problem. My 2.998, that's just about 3. We'll call that 3. But I do have a problem up here with my carbon, 3.499. That's not going to round to a whole number. That actually rounds to about 3.5. This is where the twist comes in. If you see that you have a half, it means you need to multiply through by 2. In essence, we are trying to eliminate the decimal. So I am going to take each of my numbers and I'm going to multiply by 2. So 3.5 times 2 is going to give me 7. Of course, 1 times 2 gives me 2, and 3 times 2 gives me 6. Now I have whole numbers for all 3 of my elements. My empirical formula is C7O2H6. While this is not my molecular formula, let's take a look at the molecular formulas of the known acids and just see if we can get one to match. So here's my list of all of my acids, and I have given the molecular formula for each of them. Since I only have carbon, oxygen, and hydrogen, it's actually very easy to eliminate phosphoric acid because we have no phosphorus. And then checking my molecular formulas, I see that my empirical formula actually matches here for my benzoic acid. So I do not have to worry about calculating the molecular formula because, again, my empirical formula is my molecular formula. My unknown acid is benzoic acid. Let's do one more problem in this problem set. My last problem reads, 2,4,6-trinitrotoluene, TNT, is one of the most common explosives. Calculate the empirical formula from the following data. Okay, so this time they only want the empirical formula. Again, I am given my percent composition for all of my elements. Let's assume we have 100 grams of TNT, converting my percentages to grams. Next, I'm going to take each of my grams. I'm going to use molar masses and convert to moles. Now to find my smallest number of moles, let's see, in this case, it is nitrogen. So that is what I'm going to divide all my number of moles by to find my ratios. When I do this division, I'm getting some whole numbers and I am getting some decimals. Obviously, my nitrogen is exactly 1. It turns out my oxygen is exactly 2. So those I don't have to worry about. If I look at carbon and hydrogen, however, carbon gives me a 2.33 and hydrogen gives me a 1.67. The trick here is to recognize that 0.33 and 0.67 are 1/3 and 2/3 respectively. So I need to get rid of that 3 in the denominator, which means I need to multiply all of my numbers by 3. So if I take my 2.33 for carbon and multiply by 3, I get 7, so I get a whole number. I do the same thing for hydrogen. I multiply by 3 and I'm going to get a 5. Now obviously my nitrogen and my oxygen are very easy because it's simply 1 times 3 is 3 and 2 times 3 is 6. So now I have all of my elements in whole numbers, which gives me an empirical formula of C7H5N3O6. And if you were to look up the molecular formula of TNT, you would find that this is actually it. Thank you for joining me for this problem set, and I hope you found that helpful.